Worth taking a moment to try to understand what it is about the way that the Russian algorithm is designed that makes it so much better than the naive approach that's just repetitive addition. So let's just go back for a moment to what multiplication is, at least integer multiplication. It is repeated addition. A times b, and let's focus for the moment on the case where a is even, can be written as b plus b plus b plus b repeated a times. We're considering the case where a is even here. We can regroup things as two sums, b added to itself a over 2 times, and then b added to itself a over 2 times again, and those two things added together. But it's silly to compute the same thing twice. So really, if we're doing this calculation, we could just compute it once, b added to itself a over 2 times, and then just double the result that we get. Doing this calculation here is basically now repeating the same operation over again. So each time we're doing part of the sum here, we're actually saving ourselves a tremendous amount of effort. The idea of divide and conquer is that you can break a problem into roughly equal-sized subproblems, solve the subproblems separately, and combine the results. And in this particular instance, the subproblems themselves, these two sums, are identical, so that it only has to be done once. So you're saving yourself half the effort every time that you do this. Half keeps compounding, and that's how we get down to a logarithmic number of steps instead of a linear number of steps. So this way of looking at the Russian peasant's algorithm leads to a very interesting way of expressing the algorithm recursively. The idea here is that what we're going to do is to multiply a and b together. What we're going to do is say if a is 0, to start, we can just return 0 and be done with it. On the other hand, if a is even, then just because of the derivation that we just worked out a moment ago, multiplying a times b is really the same thing as adding b to itself a over 2 times. So it's a over 2 times b, which we're going to compute recursively. So the Russian algorithm is going to go off and do whatever it does and compute a over 2 times b. And once we have the answer to that, we need to multiply that by 2 to get the answer to the original problem. So we can use a solution to this subproblem to solve the big problem. In the case where it's odd, it's a little bit more complicated. Pull one of the b's out. We're actually adding a, b's together, but a is odd. So let's pull one of the b's out and add to that, well, what's left? There's a minus 1 repetitions of b that we're adding together, but a minus 1 is now even, so we can have that. Compute what a minus 1 over 2 times b is, recursively. Once we have the answer to that, we can multiply it by 2. Well, it's going to give us what a minus 1 times b is, which is a times b minus b. So we just add the b back in and we should be good. So using the solution to this subproblem, we can compute the solution to the original problem. So this maybe seems a little bit circular, but each time that the Russian peasant algorithm is being called here, it's being called with a much smaller value of a, half as big as it was before. And that's where we're getting a lot of our mileage from. Let's actually analyze this algorithm. It's going to be the same answer as what we got for the Russian peasant's algorithm, but it's going to introduce a new tool that's going to be helpful for us analyzing lots of other algorithms.